Good afternoon, students. Today in our class, we are going to see about an important routing algorithm called ad hoc on-demand distance vector routing protocol. So, in what is the use of this protocol? Why we are seeing this in wireless networks is so in our second unit, we saw in detail about the IP routing. Okay, so the IP routing is a very important thing in the third layer of a network. So the third layer of the network is gives the IP address, which is very important for routing operations. So based upon this, our algorithm, we designed a routing protocol algorithm. What is the operation, how it works, is discussed in this session. So ad hoc on-demand distance vector routing protocol. Here, it is an on-demand routing protocol. There are two types of protocol. One of the type is on-demand routing protocol. What is the feature of this on-demand routing protocol is here depending upon the uh, demand of your receiver only, the routing process will initiates, and the path in between the sender to the router, the nodes in between the sender and to the router only update its routing table. Okay, this is an important feature. No need of updation of all the nodes in the network. Only the nodes in between a sender and receiver can update its routing table. So what is this advantage means? If all the nodes in a network is updated, a single change in a network, then it leads to a very high packet transmissions in the network, which where the packet gets lost and the energy will decreases. So depend upon the demand only, depend upon the path between a sender and the receiver, the nodes in between the sender and the receiver only update its routing table. So routing is based upon on demand. So here the an important feature is taken, which is called destination sequence number. This destination sequence number tells whether the information in the node is recent or not. For example, if the two nodes are taken taken the sender and the receiver there are two nodes in between sender and the receiver. So the sender has to choose any one of the node to continue its transmission means it will check the distance destination sequence number. So the destination sequence number of the intermediate node, which is high, it is chosen by the sender to continue its path. So the hopping will be takes place only based upon the destination sequence number. So the destination sequence number is used to determine or update the data path. So a very recent information, which node contains the very recent information is given by this destination sequence number. So beacon signal is used. Beacon signal is nothing but an initial signal. This acts as an initiative. So before data transmission, beacon signal is transmitted between two nodes to initiate the data transmission. So this will increases the bandwidth. This algorithm, this protocol, a node updates its path information if the destination sequence number of the current packet is greater than the last sequence stored at the node. Okay, so other than this destination sequence number, there are two operations can be differentiated into two types. One is route discovery and route maintenance. Route discovery is we have to find which path is best. There are multiple nodes in between a sender and a receiver. So the sender should choose which is the best path to continue its data transmission, and the route reply is unicast. If once the path is find out, then there is a single path between a sender receiver to the sender to send the acknowledgement. So the route request is broadcast and the route reply is unicast. Okay, so the nodes in between the sender and the receiver, all the nodes will contain the will receive the route request path information, but only the route reply is given to the path which is chosen by the sender again. So the route maintenance, if any error occurs, then the route maintenance will send us the route error messages. Other than this, there are also source identifier, destination identifier, source sequence number, destination sequence number, and broadcast identifier, time to live field to find out the to enhance the data packet transmission without any failure. So the destination sequence number indicates the freshness of the route. So how fresh the information is find out by the destination sequence number. When an intermediate packet receives the route request, it prepares for route reply. So the validate route is find out by comparing the sequence number alone. Okay, so if a route reply is received after timer expires, then the timer will delete the route request packet. So see, consider this is an example. This is an example of a network where it contains 15 nodes. Consider we are going to transmit a data from a source ID to the destination ID. The source number is 1 and the destination number is 15. So the source node 1 floods its request packet to the 15. So source node 1's sequence number is 1 and the destination sequence number is 3. From node 1 to nodes has, see, from the node 1, the next node can be 2, 5 and 6. So the node 1 has to choose which is the next node. So what it will verify? It will verify the sequence number. So it will verify the sequence number. If they check the routes to the destination. If no routes to the destination, then nodes 2 and 5 forwards the route request packet. So the route request packet is transmitted to the next node. What are the next nodes of 2, 5 and 6? Because 2, 5 and 6 is not the destination node. So the next path is 3, 4 and 10. So 3, 4 and 10 are the neighbors of 2, 5 and 6. Consider the destination sequence number of 10 as 4. 10 has 4 sequence number and the 3 is 1. Under this nodes, all the 3 nodes 3, 4 and 10 will compare its sequence number. So the source node 1 sequence number is 3, which is greater than the node 3 sequence number. So after 1 and then node 10 sequence number is 4, which is greater than 3. So therefore 10 is allowed to reply along the cached route to the source node. So after these 3, 2, 5 and 6, 3, 4 and 10, the route can be continued by the node 10. Why? Because compared to 3, 4 and 10, the destination sequence number of 10 is very high. So we are choosing the data path from 10. So 10 is the next node which will continue the data transmission, because 10 is the most recent route because it has a sequence number as 4. So from 10 to the destination 15, then 3. If the route request reaches 15, so from 10 it chooses 14 and then to 15, 4, 12, 15 or any other destination. The multiple routes can also reach the destination. It depends upon the sequence number. So once it reaches all intermediate routes, receiving route reply update its route table. AODV does not repair the path locally. The link breakage. Consider there is one link breakage occurs between 1 to 5. Consider this is a path 1, 5, 4, 12 and 15. Consider this is one of the routing path. If there occurs a link breakage between 5 and 11, the 5 will inform the link breakage to source node 1 and the 4 will inform it to other nodes, so that as a link breakage information is given as infinity. So this information is given to all the nodes. So until other nodes are reinitiate the routing process, it will inform with the link breakage only. So this link breakage information is passed to all other nodes. So based upon the destination sequence number, the data transmission will happen. What is the advantage of this AODV means? It routes established only on demand. The latest route to the destination is founded by the destination sequence number and the connection setup is very less. What is the disadvantages? If the source sequence number is very old and the intermediate nodes have higher destination sequence number, then it will lead to a stale entries, heavy control overhead for multiple reply packets to a single route, and periodic beaconing. Each time we are sending a beaconing signal to initiate the data process transmission process, it leads to bandwidth wastage. So these are the two advantages, three disadvantages of the AODV protocol. So in the next class, we will see about 3G networks. Thank you.